So yesterday we talked about perpendicular bisectors crossing at the circumcenter and how it was equidistant to every vertex. And then we talked about angle bisectors crossing at the incenter and how it was equidistant to every side of your triangle. And now we're going to move on to the last two. So points of concurrency wise. So the last two deal with medians and altitudes. So medians, right with the wrong side of my pen. There we go. Medians are just bisectors. I will tell you they do have to start at a vertex. So A to H, I almost said N. A to H is a median because it bisected this side. So a median, what makes something a median is it connects a vertex to a midpoint. Connects a vertex to a midpoint. Right, so here, I don't know what letter that is. We're going to go with C. I think that's a C. C to G, vertex to midpoint. So those are our medians. The medians are all concurrent again, so that point of concurrency is called the centroid. The point of concurrency of all of my medians is the centroid. And what's special about a centroid? So I always say it breaks your median into a 2/3, 1/3 chunk, right? 2/3, 1/3. So what the theorem actually says is the centroid of the triangle is located 2/3 the distance from each vertex to the midpoint of the opposite side. What? Right? What are they saying? So here from B to N is 2/3 the length of that median. Right? From B to N is 2/3 that length of the median. But I always, like I said, I always say there's a 2/3 chunk and a 1/3 chunk. Same thing here, 2/3 chunk and a 1/3 chunk. 2/3 chunk and a 1/3 chunk. So let's try it. So here it says Rx, R to X. So they gave you that whole entire median is 48. So we can take 48 and, oh, that's an 8. I'm going to erase that. 48, sorry about that, and we can cut it into thirds, right? Because remember, we're going to have a 2/3 chunk and a 1/3 chunk. So 48 divided by 3 leaves me with 16. All right, so that's 1/3. Well, Wx is my 1/3. And then my 2/3 is Rw. Well, 2 of those, so 16 and 16 makes 32. And if you add these up, you should still get 48. So the whole thing should be 48. 2/3 of that goes here, 1/3 of that goes here. 2/3 and a 1/3 chunk. Hopefully I just answered some questions. Oh, the first two. Okay, so Rw was 32 and Wx was 16. Now, I will tell you, I do want to see the math, so make sure you're showing me the math, even if it's just dividing by 3. I'm going to go ahead and erase this part, and we'll look at the next piece of information. The next piece says QW is 30. So from Q to W, they didn't give us the whole thing this time. They just gave us the vertex to the, oh my goodness, the centroid. Sorry. They gave us the vertex to the centroid is 30. So did they give me the 2/3 or the 1/3 chunk? Well, they gave me the 2/3. So if 30 is 2/3, and I just want 1/3, 1/3 would have to be half of that. So half of 30 is 15. Right? Just like when we were here, we had that this was 16. That was 1/3. 2/3 was double that, 32. So if 2/3 is 30, 1/3 would be just 15, because 15 and 15 get me 30. So let's see what they ask for. Q to Z. Well, that's 30 plus 15. That's 45. And then WZ is 15. And we're done. All right, let's try another one. So the next one gives me HD. H to D. All right, they gave me the whole thing is 21. So I need to break that into thirds. So 21 divided by 3 is 7. There's my 1/3. So 1/3 of this is 7. So this would be the 1/3 piece. And then 2 of those thirds, 7 and 7 make 14. And 14 plus 7 is 21. So we're good. So they asked for HB, which was 14, and BD, which was 7. All right, moving on to the next one. Oh, thought I got an eraser. There we go. Next one says BK. Oh, got a little wiggly there, sorry. B to K is 18. So again, they gave us that 2/3 chunk. If you just want 1/3, just cut it in half. Right? Half of that, 1/3 would be just 9. That is a 2. That's having writing issues today. There we go. So again, this was 2/3. Half of that would be 1/3. This was 2/3. Half of that would be 1/3. So CB was 9, and 9 plus 18 would be CK, which is 27. And we're done. So again, recap, medians all intersect at the centroid. The centroid makes a 2/3, 1/3 piece. Okay, centroid, 2/3, 1/3. Now the last one, we're actually not going to do this page. I just want to point out that they also have altitudes. Altitude is height, right? That's your height. So remember, for a height, it always has to start at a vertex and be perpendicular. Start at a vertex and it's perpendicular to the other side. So that's what a height is. That's what an altitude is. Again, the altitudes are all concurrent. They're all going to cross at point B here, and you would call point B the orthocenter. We're not really going to learn anything special about the orthocenter, so we're not going to do this. To be honest, there's really not much special about it, other than the altitudes are concurrent, so they will all cross in the same spot, which that's special. But other than that, they named it. There's not really any special theorems. So recap of everything. So we're not going to finish this one off, but I just wanted to kind of talk about the altitudes and that they all cross in the orthocenter. Perpendicular bisectors all cross at the circumcenter, and that's equidistant to every vertex. Angle bisectors all cross at the incenter, and that's equidistant to every side. Medians all cross at the centroid, 2/3, 1/3. And then altitudes all cross at the orthocenter, nothing special. All right, do your work, get it uploaded. Tell me if you need any help.